All right, so we're looking at our hydrolysis and buffers lab. We know that we took our salt solutions, we weighed some out, we put enough of these in 25 mils of deionized water to make a 0.1 molar solution, and we recorded our pH. I'm going to consider ammonium chloride here for no particular good reason. We know that the pH when we did this was less than 7. Please use whatever value you measured. And we've got some rules here on our hydrolysis reactions. Now, the goal on this is to write a good hydrolysis reaction. Hydrolysis is the reaction with water. We know that if we have an acid and we put it with water, we are going to make hydronium plus the conjugate base. I'm just going to shorthand that as CB for short. If we have a base and we take and we put it in water, we know we're going to make hydroxide plus the conjugate acid. This will make a whole lot more sense to you when you've gotten a ways through chapter 14. If I'm going to look at ammonium chloride, in order to write the hydrolysis reaction of salts, I have to ionize them first. So we are going to, or dissociate them first. We're going to dissociate our salt into its cation and its anion. Well, if I look at ammonium chloride, that is going to break into ammonium plus and chloride minus. Those are the ions, and we're also going to consider the inert species. Now, one of the first things you're going to do in chapter 14 is memorize your strong acids, and you're going to do that because you're going to learn that the conjugates of the strongs are inert. Inert meaning that they have no reaction with water. So we are going to ignore or simply cross off our inert species. Well, in the case of ammonium, that is going to leave us here, or the ammonium chloride, that's just going to leave us with the ammonium. So do not take and write the reaction of this. Take and write the reaction of whatever we have as our acid or base with the inert removed. Now, this is dissolved in water, so I'm going to put aqueous. I have a hydrolysis reaction, so I'm going to react it with water as a liquid. These are all weak. Weak is going to give us an equilibrium and 2 arrows. If you have a positive charge on something, it's much more likely to be an acid than a base. So we're going to consider this reaction right here, and we're going to make hydronium, AQ, plus the conjugate base. The conjugate base is what's left after I have donated that proton. And for the case of ammonium, that is going to give us that NH3 aqueous, and that is the correct hydrolysis reaction. So remember, in order, when you do these, take and dissociate the salt into the cation and the anion. Ignore the inert species. Write the reaction that is consistent with the measured pH, i.e., if it is basic, pH greater than 7, you better have a hydroxide in the product. And with one other note, if you have in the case of carbonate, where it could in fact accept 2 protons, we only do 1. So never do multiple protons lost or gained when you do your hydrolysis reactions, just do 1. All right, continuing with this lab, we're going to go to the next page, and we're going to look at our buffers. With our buffer reactions here, we recorded our pH. At this point, it should make sense that a buffer resists change in its pH, that whatever your pH of this one was, this guy dropped a little bit, this guy went up just a little bit, as compared to water, where the HCl dropped a lot when we added it, and the hydroxide gained in pH a great deal when we added it. So when we take and we do this one here, and we're doing our sodium hydrogen carbonate, make absolutely certain that you know whether or not this is acting as an acid or base, that you go back to your hydrolysis reaction from page 1 for this, and that when you do this, you use the correct K. So make sure you think about which K that you need. You are going to have to look at and have done the chapter 14 in order for this to make sense. With this in mind, we're going to look at the last one. Make sure you do your percent error, which is your actual, subtracting the measured over the actual. We don't have negative percent errors, so make sure you absolute value that and multiply by 100. The last portion of this is the pH of the buffer. This one should be straightforward. Simply use your Ka that you look up, compared to the measure, please calculate the pH. Or excuse me, calculate here your percent error. And on the last one, we are going to look at the change in this pH of the buffer after we have added the sodium hydroxide. Do not forget here that we're only adding a little. We're adding 2.5 mils of sodium hydroxide to 25 mils of our buffer. This is going to change our volumes, and you're going to need to be able to do a mole chart as you do these. All right, when you complete those, just go ahead and complete them on the paper and submit online.